Okay, I'm going to show you some further examples of how to find the derivative of a function using first principles. So let's take a different function. Let's take f of x, f of x equals x plus 1 squared, okay? And I want to find its derivative function, f dash of x. So what is it? And I'm going to use the first principles method. So limit h tending to 0 of f of x plus h subtract f of x all over h. Okay, so let's work that out. Now, first of all, this bit is easy to do because I'm just going to copy that here, but it's this bit I need to work out, and hopefully some h's might cancel out. So let's work out this bit. So let's work out f of x plus h. Okay, now what would that be? Well, x plus h, I would need to do x plus h plus 1 squared. Okay, but and that's going to take some time to work out, right? So let's actually work that out now. So that would be x plus h plus 1 times x plus h plus 1, right? That's what this means. That square means do it twice, right? Multiply it by itself twice. Well, let's expand this. It's going to be a lot to do, so let's expand it out before we bung it into there. So that's going to be x squared. Okay, let me do this in a different colour. So first of all, x times x is x squared. X times that is x. Oops, I forgot the one in the middle, haven't I? Whoops. X times this is xh, so plus xh, times that one is just x. Okay, moving on to letter h. H times that is another hx. Let me write it underneath. That would be plus xh again, so h times that. Right, h times this would be plus h squared. And then h times this would just be plus h. Okay, and then 1 times this would be 1x. And then 1 times that would be just plus h. And then 1 times 1 is plus 1. Right, okay, there's a lot to sort out. Let's see what we got. We've got an x squared. We've got plus 2xh's. We've got plus 2x's. We've got a h squared as well. H squared. And then 2 h's and then the plus 1. Okay? Right, now what we need to do is to bunghole this. Okay, this is f of x plus h. Okay, is all this. We've got to bung that into that expression that we had at the top, the first principles template, right? So limit h tending to 0. Okay, it's going to be a big fraction sign. And oh, actually, you know what? I really should work out. Oops. Well, let me go up a bit. Let me work out. I should really work out what this is expanded, right? X plus 1 times x plus 1 is x squared plus 2x plus 1, right? That's what that is. Okay, so I should really work that out as well. So x squared plus 2x plus 1. Now, put all this in. So x squared plus 2x h plus 2x plus h squared plus 2h plus 1. Subtract now. Subtract x squared. Subtract 2x. Subtract 1. Divide that by h. Right, let's see what horrible things cancel out. Right, we've got an x squared and x squared. They can go. We have a 2x and a minus 2x. They can go. We have a plus 1 and a minus 1. That can go. So what are we left with? We are left with a h squared, okay, a 2h, and a 2x h, right? Okay, now let me write that out here. So limit of h tending to 0. So what have we got left on the numerator? Right, we've got a 2x h plus h squared plus 2h. Okay, now let's see what things factor out from this top half here. Well, there's a h in each one of these expressions. There's one here, 2 of them there, and 1 there. So, okay, limit. Well, those h's can come out, can't they? So h can come out. So what am I left with? 2x plus a h plus a 2 and I'm dividing that by h, well, okay, well, here we go, we've got some cancellation here. We're not going to be dividing by 0 anymore. This h can knock that h out, and all I'm left with is the limit of h approaching 0 of just the numerator 2x plus h plus 2. Now, that means if I make h really, really small and make it practically 0, then this thing equals, okay, well, this thing here just becomes 0, so all I'm left with is just 2x plus 2. So this is my derivative function for f of x equals x plus 1 squared, right? That's its derivative function. So if you want to work out now a gradient at any point on this graph, just find the x value and bung that value into this expression. It tells you how steep that gradient is. Okay, now let's do one more. Okay, and then you should really go ahead and prove some other ones on your own. Now, right, let's pick a nasty one. Right, let's pick f of x equals x cubed. Oops, x cubed, which has a graph like that, doesn't it? Okay, so I want to find its derivative function. Right, now, so let me write down the template. We're going to use limit h tending to 0, f of x plus h, subtract f of x all over h. And that's going to be my derivative function. It's going to tell me the gradient anywhere I want. Now, this bit's fine. This bit here is okay. Alright? It's this bit that's going to take some time to work out. So let's work out the f of x plus h. And, well, what's that going to be? It's going to be x plus h cubed, right? Now, I'm not going to sit there and work out this. Alright, let me just copy it in here. I'm not going to work that out because that's just going to take forever, right? We should know by now the binomial expansion to do this, right? Pascal's triangle, remember the numbers in the NCR business, it's a 1, okay, then a 3, a 3, and a 1, right? Okay, so now let's see what numbers would go in it. Well, first thing will be an x cubed plus, then it's an x squared, h plus, then it's an x h squared plus, and then it's just going to be a h cubed, right? Okay, so that's the expanded version of that using binomial expansion. So let's take this now with this and put that into that and see what cancellations we have. Right, so my derivative function is going to equal the limit of h tending to 0, and fingers crossed some things will cancel out so I don't have to divide by 0. Giant fraction line, right, what is it? It's going to be 1x cubed, so x cubed plus 3x squared h plus 3x h squared plus a h cubed, or one of them, and then subtract. What are we just subtracting? We're subtracting an x cubed, aren't we? Yep, that's your f of x here. That's that f of x is just that there, and then I'm going to divide that by h. Right, let's see what things cancel out on the numerator. I've got an x cubed and a minus x cubed, so they can go. I think that's it really, so let's put limit h tending to 0, and what have we got left? We have a 3x squared h plus a 3x h squared plus a h cubed over h. Right, now let's see what things can factor out from the numerator. Let's see if we can get at least one of those h's coming out. Well, we should be able to. So limit h squared, h going to 0. Well, yeah, h, there's 1 in every bit, so we can take one of them out. Right, and what are we left with? Inside, we're left with a 3x squared plus a 3x h plus a h cubed, oh sorry, not cubed, squared. Right, now that h can knock that h out, so we're not dividing by 0 anymore, so that's fine. So what we need to do is see what is left. Right, so when I make h 0, okay, so what things disappear when h becomes 0? Well, that's going to go, because 0 squared 0, and then 3x times 0 is 0, so that's going to go, and what am I left with? I'm just left with 3x squared. So my derivative function is 3x squared. Now maybe you can see a connection between with what we've just got here. We started with our function which was x cubed, and we've ended up with 3x squared. Maybe you can see a connection that we can go from that to this. Maybe you spot the little trick. Instead of doing all this stuff here, maybe you can see that. But what you should really do now is you should go ahead and work out some of the following things, right? Okay, so try these out for yourself. Okay, first of all, do f of x equals x to the power 4. Right, so use the binomial expansion and show that the derivative function for it is 4x cubed. So can you do all the working out like we did above for this one and show that it equals that? Okay, can you do that? You should really try it. Okay, try that first one. Okay, then try this one. This one won't be that bad. Try 4x squared. Okay, the function, and then show that its derivative function is just 8x. Alright, try that. And if you want to try one more, have a go at this. Okay, have a go at this function. You should try this one. 5x cubed. This won't be that bad. Factor the 5 out. Try and show that it is 15x squared. Okay, so do all the working out for above and show that this one, this derivative function is that, and then this one's derivative function is this, and then this one's derivative function is that. Okay, alright, this last one's probably a nasty one because of that 5 there. Okay, that might cause you some problems. Okay, use the binomial expansion on that one. So see if you can do it. But maybe you can spot the little trick that I've done to work these out quickly. Okay, because I'm not going to sit. I've not sat there and done all of that stuff above. There's a little trick to get these. Okay, so you try it yourself. Okay, it's really important that you sort of nail this. Okay, that you really got to get this, because they like to ask you questions on this all the time in the exams. So make sure you know this. Okay, get this in your head. Right, so practice it until you get it. So you should really spend some time, good amount of time working through these 3 examples here. Okay, so I'll leave it to you to have a go at them.